One of the most unreliable pieces of equipment that I own is these digital cable receivers. And I think I have explained in other videos what I use them for. I have a stack of these digital receivers. The other ones are Memorex, this one's an Apex. And I have them dedicated to one single off-air channel. And each one, I have a total of 5 of them. Each one picks up one of the local stations. And I just put them on a separate carrier and feed them throughout the house. And the reason I do that is because I don't have a digital TV in every room that's got a TV. There's a lot of TVs in my house that are not that do not have digital tuners in them. They have just an analog tuner. And I do have a cable TV service, but the problem is that requires a box on every TV. I don't have a box for every TV. I have a couple boxes for the main TVs. The other TVs I just watch local programming on. So to watch the news or sports or something in standard definition is not that big a deal. I don't need high definition on them all. So I've got these little crappy boxes. The problem is these things just don't last. Here's another example of wonderful technology, but they're not built to last. This one's gone completely dead. I plug it in. I have no standby power and I have no power. So we're going to have a power supply problem on it. Now this unit worked. It worked fine up until we had a power failure. We had a power failure here a couple weeks ago, or a power bump, I should say, a couple weeks ago. In fact, that power bump happened right when I was in the middle of making a video. And the next thing I know, 2 of these boxes are dead. So let's take this one apart and see what the guts of this one looks like. These units are not very expensive. They're very, very inexpensive unit, and they weren't really built to very high standards. They were basically marketed, and people would get them with the coupon, so they could get them for next to nothing during the transition period from analog to digital in the United States. I already see a bulging capacitor right here. That's more than likely the fault. This is a 2200 400 volt. So this is going to be one of the capacitors on the input. These are the ones on the secondary side here. That one there, though, I can see the top of it's lifting a bit. So this may be the problem here. And this is probably one of the main filters, or even could be in the startup circuit. I believe this little one down here, this is probably the capacitor that kicks the oscillator into running. So, but I can see the top on this one looks like the top is a bit raised, just from my angle here anyway. Maybe not, but let's replace it. I've got some high voltage capacitors out of other power supplies, so that won't be an issue to change that. Let's get the power supply out on this thing, take a look and see what's going on with it. Okay, I've carefully removed the circuit board. It is not plugged in, it is unplugged. But remember, these are the capacitors on the input side of the oscillator. We've got no standby, so the oscillator is not running, so there's nothing to discharge these capacitors. So there's a good chance that there's still going to be one heck of a charge stored in these capacitors, and we'll just show you. I'll get the meter out here. This thing's been sitting now for about 10 minutes and has not been plugged in. We'll just get the meter out and we'll just measure and see if there's any voltage on these capacitors. Now, I'm being very careful not to touch anything on here, because if I touch these, I'm going to get a good jolt. There could be several hundred volts stored. They're small capacitors, only 22 microfarad, but they can still store a nasty charge when there's no load to discharge them. So let's just take a look here and see that. Look at that, we have 246 volts. We're going to discharge these capacitors just so that I can work on this thing safely. A couple ways to do it. The easiest way is just to take a jumper lead and short them out. Now they're dead. I don't have to worry about getting bit. As you'll see. Oh, we got 2 volts on there, but who's worried about that? I think those caps are okay. I think the problem on this one is probably... Oh, no. This is a write-off this unit. I can see the problem with this unit right now. I can see the problem with this. We have a blown oscillator driver IC. So unfortunately this unit is not going to be repairable unless I can find another one of these little ICs. I don't even know what it is, but you can see it. You see the top? Right here, there's a whole chunk missing out of the top of this. Up on my workbench tonight, or today, is another one of these troublesome Memorex converter boxes. Power says it turns on. I got no video, nothing. These things have become they're just really unreliable. Seems like all I do is spend time fixing these things, and I just had 2 more of them break down. I had I think it's an Apex box that died. Just took a look at that one, and as you saw in the video before this one, that it's beyond repair because one of the ICs, at least unless I could find a power supply for it or find out what the IC is. I don't even know what the number of it is because there's a big chunk missing out of it. But both of these ones went dead at the same time, and it happened during a power event. I had a surge there and it blew these ones up. These ones have all been repaired in the past. They've had capacitors that have gone bad in their power supplies, which causes them not to turn on. But today this one's got a bit of a different problem. This one turns on, I just don't get any video out of the output. So we have a different problem. It still could be power supply related. Let's dig into this thing and see what's going on with it. So on this unit we've got several power supplies, several voltages on here. Let's just check some of the voltages. What's nice about it is the voltages are actually labeled on the board as to what the voltages are supposed to be. So it's easy to see if we've got a voltage that's low. So the first thing we'll check is the 12 volt supply, which is this one right here, and we'll find that the 12 volt supply is 0.2 volts, 0.1 volts. And this unit is supposed to be turned on. The green light is on, but there's no 12 volt supply. The next one we're checking is the 7 volt supply, and it is coming up to, turn it back on. It's only coming up to 4.4 volts when it's turned on. The 12 volt supply's got nothing. How about there's another supply down here. It's a 4 volt supply. So the 4 volt supply is the 4th pin over, and it's 0, as is this one here. There's a 4 volt supply there. So the 4 volt supply is working, and the 4 volt supply there is working. The 7 volt supply is only coming up at 4.4, and the 12 volt supply is 0.3. So we know that we definitely have a power supply issue on this one, and I'm going to guess it's one of the capacitors that's bad. These ones have been replaced in the past. These are new caps that I replaced in this thing about a year or so ago. We may have another one that's gone bad. Let's get the ESR meter out. We'll do some testing and see whether we've got another capacitor that's bad on here. My guess is that we have another cap that's gone bad, and that's why this unit's not working. So we'll just unplug the board. Gotta be careful with these ones because the circuit glue that they put on gets really quite nasty, and it actually makes this plug break. This is this crappy glue that they put on, and it actually goes corrosive after a while, and gets conductive, starts to short things out. So we want to try and remove this glue if possible. This can short out and cause the power supply to overload. So we're going to just try to clean this stuff out here. I don't want to break this connector though. I broke the connector on one of the other ones, and I had to hardwire the wires right into the circuit board. So I just want to try and scrape this stuff off here as best as possible without damaging the board. And we'll get this power supply out and see what's going on with it. Okay, we're going to put the ESR meter across this capacitor that I suspect is bad, which is this one right here. And it's one that measuring, well, it's measuring 0.00. I was like, it's got a short. This this is the diode here off the main transformer. So this is one of the main filter rectifiers is this one here. Let's just take it out of the circuit and we'll just check it again out of the circuit because the loading could be coming from something in the circuitry. Again, these units are not very reliable at all. I mean, I do leave them running 24/7, so they are taking a pounding in operation here, but it seems like I have to fix these things like once a year. Okay, now we can see the true colors. This capacitor has actually gone open. We look at it here. I'll put my probe on, put meter on here. This cap's gone open. So I was seeing loading. There's actually another capacitor in parallel with it. That's why I took it out of the circuit. It's got this one here in parallel with it. So let's just change this one and see if I get back my 12-volt supply. This is 470 at 16 volts. I'm sure I can find something that's a little better than that. So what I'm going to do here is I'm going to put two 330s in parallel with each other. It just so happens that there's another set of holes on the board, and the ground is on the negative is ground terminal is the going to the common foil on the board. The positive terminal is going to a foil trace that's not connected to anything, so it's just a matter of putting a jumper wire in place, and I can have two of them in parallel. That'll give me a couple benefits to paralleling capacitor. To give me more capacity for one, but it'll also effectively lower the ESR even lower. And some manufacturers do that. That's what they do, is they'll put multiple capacitors in parallel to, instead of putting a big one in, like for example, if you want 1,000 microfarads, instead of putting 1,000 microfarad cap in, they'll put a couple 470s or a couple 560s in there in parallel to get the capacity up to what they want, but it also lowers the ESR, or the equivalent series resistance. The second capacitor added here is right on this trace, and this was actually for, it's right here. There's nothing connected to here, and there's nothing connected over here. This is our positive lead here, this is our negative. Negative is on the shield, which is also connected to the negative of this other capacitor here. This is the other one I replaced. So if I just bridge across here, this is the positive terminal of the bad cap. If I bridge from here to here, that'll put this positive terminal to this one. It'll put those two capacitors in parallel with each other. And that's what we want. So I'll just get a piece of wire. So now what we've done is we've bridged two capacitors in parallel with each other. We've got the one that was bad, which is right here. This is its trace that goes to this coil, which actually has another capacitor in parallel with it over here. There's a coil here. So this is the capacitor here, and then I bridged it to this other capacitor here. Negative, positive, positive, or sorry, negative, positive here, positive, negative. The two negatives are connected together in parallel. I bridged the positives in parallel. Just make sure that there's no short circuits here, and we'll put this back in and see whether we get video. See whether we get a picture off this thing. Carefully reinsert this plug. It's disintegrating every time I unplug it. Oops, one pin just fell out. That's what I was afraid of. The problem with these plugs is that the plastic is so brittle that you just take them out a few times. That's caused by this circuit glue that they put on. So we'll just kind of seat that in there. I think if this has to come apart again, I'm probably going to have to hardwire this connector in like I did on one of the other units like this. Okay, now that we've got that connected, we'll connect the antenna. There's the antenna in. This is just going to an antenna on the roof of my house, and we'll apply power. Got the red light on. Turn on the power. DTV tuner is booting up. I pan the camera up here to my little test monitor. We'll see whether we get a picture. No picture. Try a different channel. Here we go. You guys probably can't see it because of the rolling shutter on this stupid camera, but it works. We have sound, we have picture. And I'm going to do a channel scan all the channels in and see what we get on this thing. So to scan the channels in, you need the remote control. You press the menu button. It might help if my batteries are good in here. Just make sure that the batteries are working because they haven't been used in a while. Menu. Here we go. And we want to set up the channel, so we want to auto scan the channel. Now, the reason you have to do this from time to time with these digital boxes or even your digital tuner is because the TV stations sometimes will remap their channels. They'll change formats. They may add channels, add virtual channels. So it's a good idea to rescan your channels once in a while just to pick up any new features that they may have added, such as additional channels. So we're going to let this go through this scanning process here. It's going to take a few minutes. As you can see, channels are starting to appear now. So once the system goes through all the channels, we can just press the exit key. And now we're able to scan through all the channels using the channel up and down key. It'll show us all the channels that we're going to get. So I'm going to get here I'm not getting CBC for some reason, but I'm getting Global, getting City, getting Me TV, getting Movies. Now the antenna is not facing the right direction for this channel, so I'm not surprised that it breaks up. Same with that one. I'm going to get CTV2. Religious channel and a shopping channel. French TV, CTV1, and Omni. And back to the same. So here we go. Fixed another one. How long this one will last? Hopefully it'll last a little longer now that we've got a couple capacitors in parallel here. It'll drop the ESR and hopefully this thing will last a little longer, but if it's like the rest of them, it's a regular ongoing problem with these power supplies. I have three of these units. All three of them have had power supplies fail, and it just seems to be an ongoing thing. About once a year I gotta go in and rebuild the power supply. So this will be good until it goes again, and one of the other ones will probably go prior to that, and we'll be back here looking at this thing one more time. Thanks for watching, and we'll catch you in the next video.